All right, so who's got something you want to look at now? Foster, was your hand going up?
No.
I wish it were. What you're telling me is you didn't even bother to look at the review sheet. And that just really frustrates me. Olivia?
Look at 26.
26. I gotta find that right here. Okay, 26 is what we just did, right? This is the most recent lesson we have had this year. This was the very last thing we did. So, everybody should remember what to do here. What do we do?
0.07.
So, you gotta separate the 0.2, and then you have your 0.07 and your 0.007, and so on with your sevens. Okay, then what?
0.07 over 1 minus 0.1.
She did that perfectly. Why is she putting it over 1 minus 0.1?
Because there's only one.
Because only the 7 is repeating, right? So this is 0.07, over 0.9. Now we're going to move those decimals a couple of places. 1, 2, 1, 2, which is going to give me a fraction of 7/90ths. That does not reduce or anything. But I still have this 0.2.
Plus 2 over 10.
So I have to add the 2 over 10. Get a common denominator. So I have 7 plus 18, which is 25 over 90. That actually does reduce by 5s. So that would be 5 over 18. And then, well, this is not a calculator problem, but if I had a calculator, I could check it real quick by doing 5 divided by 18, right? And sure enough, we get 0.27777. Okay, we'll get our quest back next time. I still have some people to take it, yeah.
The water in the SLC turned orange, and I was trying to find a good bathroom to wash my hands. It turned orange again.
What turned orange?
The water in the SLC and a beer.
The water?
That water is
Orange water.
It's orange. That's a good excuse.
Yes, sounds like orange, but yes, Four D. Now there is a way to do this on the calculator, but since it's a no calculator problem, I guess I better figure out how to do it by hand. Would you agree? So what do you know about the numbers 9 and 27? Those are not random numbers. They're both powers of 3. 9 is 3 squared. And 27 is 3 cubed. Hey, Kai? Now, this process that I'm getting ready to do here finished can only be done if the numbers are, am I on the wrong problem? People are looking at me.
It's 4.
Oh, my sheets are stapled together, so sorry about that. Well, but it's the same idea, right? What's special about 4 and 8? 2. They're both powers of 2. So this process that we're doing here can only be done, make sure I'm on the right page. Can only be done if the numbers are both powers of the same base. So this is 2 squared, and this is 2 cubed, right? yesterday we did a problem, or whatever day we were last together, where we had an exponent to another exponent. What do we do when we have an exponent to another exponent? What do we do to those? They do not cancel. What do I do with them? I don't add them. I multiply them. You guys, this is something you absolutely have to know no matter what math class you end up taking. This is basic, basic, basic. When you have two exponents, a power to a power, you multiply. When you have an x times an x, you add. Instead of guessing and getting it wrong, write it out. Doesn't this mean x squared times x squared times x squared? So how many x's are there? 6? And this means xx, xxx. How many x's are there? 5? Write it out, work it out if you can't remember. But honest to God, that is something at this point in your life you should know. All right, so these are going to get multiplied. So 2 to the 4x minus 6 equals 2 to the 9x plus 3. Now, what's sort of logical at this point? What just sort of makes sense? If 2 to this power is the same as 2 to this power, what makes sense? Set them equal. The powers are equal. If 2 to this has to be 2 to this, whatever 4x minus 6 is, it has to be the same as 9x plus 3. You can only do that if these two numbers are the same base, or can be made into the same base. Then you solve. So 5x equals negative 9. It looks like x equals negative 9 fifths. The one I started would be done exactly the same way. Only they were powers of 3. But that doesn't change how you do it. That is different. Let's see, that was for D. Now look at 4E. Is it kind of the same? Yeah, it's structured the same way, but what is really different? You cannot, well, it actually does, it's a 1, which you can add in or not add in, that's up to you. But what about the numbers 8 and 11? Can I make them 2 to something, or 3 to something, or 4 something? Can I do that with them? No. So this is a calculator problem, because the only way to do it is to take the logarithm of both sides. If you cannot get them to be the same, if you can't make 8 and 11 the same, the way we made 4 and 8 the same, if you can't do that, then you need logarithms. And who remembers what happens once I take the logarithm of both sides? What am I allowed to do? What happens to this? Comes out in front. So x plus 1 log 8 equals log 11. Now this is a calculator problem, so I'm going to end up typing this in on my calculator. I'm going to divide by log 11, or log 8, I mean, divide by log 8. So x plus 1 equals log 11 over log 8. And then I'll subtract 1. So you should type that in and make sure you get what I got. Remember, especially, I think it's for sure with the old calculators, I'm not sure about the new ones. When you type in log 11, you have to close that parenthesis. So log 11 divided by log 8, and then subtract 1. You should get 0.1531. Ethan?
Do we do 22?
22. If a student is late, the probability he's in uniform is 38%. He's not late, it's probably in uniform. All right, so Ethan, when we read that problem, what strategy pops into your head? The tree, thank you, Chloe.
Oh.
This is a tree diagram. The two things happening are being late and being in uniform. The question says, find the probability he'll be in uniform. So the first branch of our tree is late and not late. And the second branch is uniform and not uniform. Because remember, when you set up your tree, the last level of the tree, the bottom level of the tree, has to be the question. And the question is about uniform. So if a student is late, his probability is 0.38, which means this probability is 0.62. If a student is not late, his probability is 0.68, which means this is 0.32. We have a calculator for this, so it can help you with all the arithmetic. 24% are late, which means 76% are not. And we want to know that he will be in uniform. So we want this one and this one. He will be in uniform. So remember what we do once we get our tree made? We multiply these two, so 0.24 times 0.38. 0.24 times 0.38 is 0.0912. And then 0.7, we want this one right here. So 0.76 times 0.68, 0.5168. What do I do with those two numbers? Add them. So plus 0.012. And the answer is 0.608. So it's fine to say 0.608. If you want to give a percentage, that would be 60.8% are in uniform. All right, what else? Who else found one? 21, a 5-card hand is self-standing deck. What is the probability of at least 3 aces? What does at least 3 mean? You could get 3 aces, or we could get 4 aces, or we could get 5 aces. It's a 5-card hand. Does that bother anybody? You can't get 5 aces because there aren't 5 aces, right? So we are looking at either getting 3 aces or 4 aces.
Yes.
All right, how many aces are in the deck? 4. I want 3 of them. 4C3. But this is a 5-card hand, which means if I have 3 aces, I must have 2 of something else. So how many something else cards are there in the deck? 48. And I need 2 of those. So this is 3 aces and 2 others divided by, what's the total number of hands? 52C5, if they're 5-card hands. So that's 3 aces. Now what does 4 aces look like? Well, 4C4 times 48C1. Now I only need 1 other card. 5-card hand, 4 aces, 1 something else. and it's also over 52C5. What are you gonna do with those two numbers? This number, this is gonna be a number, and this is gonna be a number. What are we gonna do with them? Add them. It's or. It's 3 aces or 4 aces. Now your calculator, believe it or not, will do that all at once. So you can type 4C3 times 48C2 divided by 52C5, just hit equals, and then plus 4C4 times 48C1 divided by 52C5. I got 0.00175. Is that what you got? 0.00175? What makes these problems tricky is that when they say 3 aces, sometimes you forget about those other 2 cards. But you gotta have 5 cards altogether. So if 3 of them are aces, you have to have 2 of something else. All right, who else on practice test or review 1, the first review sheet here? Test, but I'm going to go ahead and graph it because there are other things besides vertical asymptotes and y-intercepts that we might need. There are other things besides that. So I'm going to put everything in here, even though this particular question only asks 2. I think if you look at the other review sheet, it asks you for different things. So let's just review how to find everything. All right, how do we start? What do we do first? Say it with confidence. Factor. Now, at this point, what happens sometimes? Sometimes something will cancel. If something cancels, you'll have a hole in your picture, but we aren't going to have one because none of those match up. Okay? What do we have here? When you look at this problem, what do we have? The things we need to be able to identify are vertical asymptotes, horizontal asymptotes, x-intercepts, and y-intercepts. So look at the problem right here. What do we have?
We have the same
Well, they're different factors. They both got 3's on the bottom and 1's on the top, but one's plus and one's minus. No, nothing cancels. Oh, no.
Did you say we would have to graph it though?
You don't have to graph, but you have to be able to find all this information. So I'm going to graph it so we can see it all. But you're going to have to be able to find all that information, which right now no one seems to be able to do.
You box in the highest powers, but I don't know if it's
Okay.
vertical or horizontal.
Okay, she says, with a little bit attitude, you box in the highest powers, but I don't know if it's vertical or horizontal. Well, if I go back to the original problem, I have x squared over x squared, which makes 1. So is that my vertical asymptote or my horizontal asymptote?
Horizontal.
That's my horizontal asymptote. So my horizontal asymptote is y equals 1. Guys, to put that in context, if I said to you, what's the limit of x squared minus 1 over x squared minus 3, I hope you would tell me that the limit is 1. You had to do that on your quiz yesterday, or the day, whatever it was. That's 1. The horizontal asymptote is the limit. All right, so we got that one down. Good. That was not one of our questions, though. Who's talking? Chloe, what'd you say? You've been right every time you said something today, Chloe, so say it again. What?
I don't know if it's right or not. You said that one of them equal to 0.
Actually, you said a lot of things equal to 0. What would, if I set these equal to 0, what would I get here if I set this equal to 0? I get a vertical asymptote at x equals -3, and I get another vertical asymptote at x equals 3. So my vertical asymptotes, most of our pictures don't have 2, but this one does. X equals -3 and x equals 3. Those are my vertical asymptotes. Now what happens if I set the numerators equal to 0? The numerators equal to 0 give me x equals -1 and +1. Those are my x-intercepts. My x-intercepts are -1, 0, and 1, 0. If I'm you and I can't remember this, I am making notes, good notes, and I'm saying, where do vertical asymptotes come from? Set the denominator equal to 0. Where do x-intercepts come from? Set the numerator equal to 0. Now, there's only one thing left, and that's the y-intercept. How do I find the y-intercept? Always, no matter what the equation is. Trigonometry, logarithms, anything. How do I find the y-intercept? Let x equal 0. If I plug in 0, my y-intercept is 1, 9. You do not have to graph on your exam, graph one of these anyhow on your exam. If you were graphing it, you have to be able to find all this information, just like we did here. Here we needed the vertical asymptotes and the y-intercept. But you could need any of that. If I were drawing this, can you kind of see this shape right here? And then what's happening on the outsides? You've done enough of these, you know what's happening on the outsides. This and this. That would be the whole picture, if by chance you needed it. All right, time for a couple more. Who else has a question about one of the questions, one of the 20? 20. All right, number 20 says, number 20, in how many ways can I choose 3 boys and 3 girls from a group of 6 boys and 7 girls?
What number is 20?
Number 20. Okay, you 3 back there, please stop. You're distracting. What is with our hair? Always playing with our hair.
It's a poop right now. I mean, I can't do that with touch right now. I don't know why.
I know, and that's okay, but stop worrying about your hair and worry about your math grade, okay?
I'm not afraid I'm bad, man. It's just bad because I missed the place.
I'm not gonna argue with you. I've done this for a long time. I just want you to be prepared. All right. How many ways can I choose 3 boys and 3 girls from a group of 6 and 7? All right, what's your thought? We just did, this was recent stuff too. What's your, oh, listen to her. She's an amazing human being. She says 6C3, 7C3, because you're picking 3 from the 6 boys and 3 from the 7 girls. So I can type that in on my calculator, and I can type that in on my calculator. What do I do with these two numbers? Multiply. You are picking girls and boys. When do we add? When it's or. When I can do my homework or not do my homework, right? Then I add. But if I am picking a boy and a girl, I have to multiply. Read the problem. If you're doing it and, it's multiply. If you're doing it or, it's add. Okay, who else?
23.
Which one?
23.
23. Alyssa's preparing a speech. She may choose from 4 different types of speeches, 3 different lengths, and 12 different topics. How many possible speech choices does she have? You multiply them all. That's exactly right. So she has 4 choices for her speech. She has 3 choices for her length, and she has 12 topics. So the answer is 144. Now, if that's confusing to you, or you're thinking, oh gosh, stop a minute. In this problem, we were picking boys and girls, right?
Yes.
So we said, okay, we have 6 boys, and we're gonna pick 3 of them. So how many speech topics, or how many, what's first, how many types of speeches does she have? 4, and she has to pick 1. So if you want to do this problem like that one, you can. 4C1 times 3C1 times 12C1. And that will multiply together and you get 144. It's exactly the same thing. Only Alyssa is only picking 1 of each group. Over here, you were picking more than 1. You're picking 3 of each group. But if this makes more sense to you, do it this way. That will give you exactly the same answer. Okay, 1 more. Who has 1 more? I think. Let me check my time. Yeah, 1 more. Gabe?
1B.
Now, these were the easy ones back when we did this. Everybody thought these were the easy kind. Who remembered, C is a harder one, but I'm not making you do one like C. Who remembers how we start this? What do we do first?
Switch 1 over.
So we change them all into sines and cosines. Now, if it's already a cosine, I always put it over 1. You don't have to do that, but don't change it. It's cosine. What's tangent? Sine over cosine. Good. What's secant? Reciprocal of cosine. So this is 1 over cosine squared. And then sine is just sine. So we're going to change everything except the sines and cosines. Then what happens? That's all multiplication. So now we just start canceling. So that cosine will cancel with that. Oh, I think that's it.
Yeah.
So what am I left with?
Sine squared x over cosine squared.
Yep. What's sine over cosine again? Ethan just told us sine over cosine is tangent. So this is just tangent squared. All right, we have 1 more review time, and that is next Monday.